Download this code from codegive.com, link in the description below. Configuring static VTI site-to-site VPNs on Cisco iOS devices, a comprehensive tutorial. This tutorial provides a detailed guide to configuring static virtual tunnel interface, VTI, site-to-site VPNs on Cisco iOS devices. VTI offers a more streamlined and flexible approach compared to traditional crypto map-based VPNs, providing a rooted interface that simplifies routing configurations and supports advanced features like QoS and multicast. Understanding VTI and its benefits *. A VTI, virtual tunnel interface, is a virtual interface that represents a tunnel endpoint. Instead of relying on crypto maps that tie crypto configurations to physical interfaces, VTI presents a logical interface with its own IP address. This allows for *simplified routing. VPN traffic is treated like any other routed traffic, making integration with existing routing protocols, RIP, eigrp, ospf, BGP, seamless. QoS support apply QoS policies directly to the VTI, ensuring prioritized handling of VPN traffic. Multicast support VTIs inherently support multicast traffic, making them suitable for applications requiring multicast communication across the VPN. Reduced complexity. Configuration is generally easier to understand and troubleshoot compared to crypto map-based VPNs. Scalability. Easier to manage multiple VPNs. Topology. We'll use a common site-to-site VPN scenario. Assumptions. Both routers have basic connectivity to the Internet, simulated by Internet 0/0. Internet-facing interfaces are configured with appropriate IP addresses. Basic router configuration, host name, enable password, has been completed. The routers can ping each other's public IP addresses. This is crucial for establishing the VPN. Configuration steps. Router A. 1. Configure IKF2 profile, authentication and key exchange. Crypto IKF2 proposal_A, defines the encryption, integrity, and Diffie-Hellman group used for IKF2 negotiation. This must match on both sides. AES 256 specifies AES encryption with a 256-bit key, SHA-512 provides strong integrity hashing, and Group 14 uses DH Group 14, 2048-bit MODP, for key exchange. You can use other combinations, but ensure they are compatible. Crypto IKF2 policy_A, links the proposal to a policy. Crypto IKF2 profile_A, defines the parameters for the IKF2 session. Match address local 203.0.113.1, critical. Matches based on the local device's external IP. It is used for identifying that the router is responding to IK requests sent to its public IP. Match identity remote address 198.51.100.155.255.255.255 matches based on the remote router's public IP address. Using 255.255.255.255 specifies an exact match, which is the most common and secure approach. Authentication remote pre-share and authentication local pre-share, specifies pre-shared key authentication. Press *your_strong_ pre-shared_ key, replace your_strong_ pre-shared_ key with a strong, randomly generated key. This is a critical security parameter. The pre-shared key must be identical on both routers. Lifetime seconds 86400, sets the IKF2 Security Association, SA, lifetime to 24 hours. You can adjust this as needed, but it should be the same on both routers. 2. Configure IPsec transform set, encryption algorithm. Asterisk crypto IPsec transform set ESP 256 ESP SHA-512 HAMAC, defines the encryption and authentication algorithms used for IPsec. Asterisk ESP 256, specifies AES encryption with a 256-bit key using the encapsulating security payload, ESP, protocol. Asterisk ESP SHA-512 HAMAC, specifies SHA-512 HMAC for data integrity and authentication. Asterisk mode tunnel, specifies that the IPsec connection is a tunnel, encapsulating the original IP packets within the IPsec header. 3. Configure crypto profile, link IKF2 and IPsec. Asterisk crypto IPsec profile IPsec, defines the IPsec profile. Asterisk set transform set, associates the transform set, encryption algorithms, with the profile. Asterisk set IKF2 profile A, associates the IKF2 profile, authentication and key exchange, with the IPsec profile. 4. Create and configure the virtual tunnel interface, VTI. Asterisk interface tunnel 0, creates the virtual tunnel interface, VTI. You can use any available interface number, example tunnel 1, tunnel 100. Asterisk IP address 192.168.1.155.255.255.0, assigns an IP address to the VTI. This is the tunnel IP. Ensure the IP addresses for tunnel 0 on router A and router B are on the same subnet but are different addresses, example 192.168.1.1 and 192.168.1.2. Asterisk tunnel source gigabit Ethernet 0/0, specifies the physical interface that is the source of the tunnel. This is your public interface. The router will use the IP address configured on this interface as the source IP for the IPsec packets. Important, ensure this matches the IP in the IKF2 profile. Asterisk tunnel destination 198.51.100.1, specifies the destination IP address for the tunnel. This is router B's public IP address. Asterisk tunnel mode IPsec IPv4, enables IPsec tunnel mode using IPv4. Asterisk tunnel protection IPsec profile IPsec, applies the IPsec profile to the VTI, linking the encryption and authentication settings. Asterisk no shutdown, enables the tunnel interface. 5. Configure routing asterisk. Asterisk IP route 10.2.2.02555.255.255.0 tunnel 0, creates a static route that directs traffic destined for router B's internal network, 10.2.2.0/24, through the tunnel 0 interface. This is crucial for routing traffic through the VPN. Configuration steps, router B. The configuration on router B is similar, but with the IP addresses reversed. 1. Configure IKF2 profile asterisk. Asterisk important, use the same pre-shared key as you used on router A. The proposals and policies must match exactly, including encryption and hashing algorithms. Match address local should be the public IP of router B. 2. Configure IPsec transform set asterisk. Asterisk must match router A's transform set exactly. 3. Configure crypto profile asterisk. Asterisk must match router A's crypto profile in terms of which transform set and IKF2 profile are linked. 4. Create and configure the virtual tunnel interface asterisk. Asterisk IP address must be on the same subnet as router A's tunnel 0 but with a different IP, 192.168.1.2 in this example. Asterisk tunnel source should be the public interface on router B, example gigabit Ethernet 0/0. Asterisk tunnel destination should be router A's public IP address. 5. Configure routing asterisk. Asterisk route traffic destined for router A's internal network, 10.1.1.0/24, through the tunnel 0 interface. Verification asterisk. 1. Check IKF2 Security Association asterisk. On both routers, use the command. Look for a state of established. If the state is something else, example mm_wait_message2, I_SPI, there's likely a problem with the IKF2 configuration, pre-shared key mismatch, IP address mismatch in the profile, or other configuration errors. Pay close attention to the output, which often provides hints about the problem. 2. Check IPsec Security Association asterisk. On both routers, use the command. This will show the IPsec Security Associations, SAS. Look for inbound ESP-SAS and outbound ESP-SAS sections. Ensure the SPI, Security Parameter Index, values are present and that the counters, packets in cap/decap, are incrementing as traffic passes through the tunnel. 3. Ping across the tunnel asterisk. From a host in the 10.1.1.0/24 network, ping a host in the 10.2.2.0/24 network, and vice versa. If the pings are successful, the VPN is working. If not, troubleshoot the routing configuration and the IPsec/IKF2 setup. 4. Traceroute asterisk. Use traceroute, or tracert on Windows, to confirm that traffic is flowing through the tunnel. The traceroute should show the tunnel IP addresses, 192.168.1.1 and 192.168.1.2, as hops in the path. Troubleshooting tips asterisk. Asterisk pre-shared key mismatch asterisk. This is the most common error. Double check that the pre-shared keys are identical on both routers, including case sensitivity. Asterisk IP address mismatch asterisk. Ensure that the match address local and match identity remote address commands in the IKF2 profile are configured with the correct public IP addresses for each router. Also verify that tunnel source and tunnel destination statements are correct in interface tunnel 0. Asterisk routing issues asterisk. Verify that the static routes are configured correctly and that the routing table reflects the routes. Ensure that there are no overlapping or conflicting routes. Asterisk firewall issues asterisk. If a firewall is present between the routers, ensure that it allows UDP traffic on ports 500 and 4500, IKF2, and ESP, IP protocol 50. Asterisk NAT issues asterisk. If either router is behind a NAT device, ensure that NAT-T, NAT traversal, is enabled. Cisco iOS typically handles NAT-T automatically. Also ensure the NAT device is configured to forward UDP ports 500 and 4500 as well as ESP, IP protocol 50, to the internal router's public IP address. Asterisk MTU issues asterisk. Sometimes, large packets can be fragmented and dropped. Try adjusting the MTU, maximum transmission unit, on the tunnel interface and physical interfaces to smaller values, example 1400 bytes. Advanced configuration options asterisk. Asterisk dynamic routing protocols, eigrp, ospf, BGP. Instead of static routes, you can run a dynamic routing protocol over the VTI. This allows the routers to automatically learn and adapt to network changes. You would configure the routing protocol on the tunnel 0 interface. Asterisk quality of service. QoS apply QoS policies to the Tunnel 0 interface to prioritize certain types of traffic passing through the VPN. This is especially important for latency-sensitive applications like VoIP or video conferencing. Dead peer detection, DPD. Configure DPD to detect when a peer is no longer reachable and automatically re-establish the VPN tunnel. This improves VPN reliability. DPD is enabled within the eigrp profile. Multiple subnets. If you have multiple subnets behind each router, you need to add more static routes, or use a dynamic routing protocol, to ensure that all subnets can communicate across the VPN. Careful planning is needed to avoid overlapping subnets. Security considerations. Strong pre-shared key. Use a strong, randomly generated pre-shared key. Avoid using easily guessable passwords. Regular key rotation. Change the pre-shared key periodically to enhance security. eigrp security. Use the strongest encryption and authentication algorithms supported by your devices, example AES-256, SHA-512. Access control lists, ACLS. Consider using ACLS to restrict access to the VPN tunnel based on source and destination IP addresses and ports. While VTI simplifies things, still use a crypto access list in conjunction. Monitor logs. Regularly monitor router logs for any suspicious activity or errors related to the VPN. Example configuration, complete, router A. Example configuration, complete, router B. This comprehensive guide should provide you with the knowledge and steps necessary to configure static VTI site-to-site VPNs on Cisco iOS devices. Remember to replace the placeholder values, pre-shared key, IP addresses, with your actual configuration parameters. Always test your configuration thoroughly before deploying it in a production environment. Remember to save your configuration using copy running config startup config. Good luck.